So we're going to talk about Poisson distributions right now. These can be used as an approximation to binomial distributions. So let me recall for you, let me go back real quick, that if you have a binomial distribution, the mean can be expressed by n times p, which n is the number of trials. Times the probability of each trial. And then Poisson, actually, the mean is just lambda, so that means n times p is equal to lambda. But as n goes towards infinity, so as you have an infinite number of trials and the probability tends towards 0, the binomial tends towards the Poisson distribution's value. So like they'll calculate the same thing only using two different formulas. With that being said, let's look at these Poisson distributions. So Poisson distribution can be used to compute the probability of experiments in which a random variable x counts the number of occurrences, aka successes, of each particular event within a specific specified interval. The criteria is the following. So you've got a fixed number of trials, and it follows the process provided by the conditions are met. Provided the conditions are met. The probability of 2 or more successes in any sufficiently small subinterval is 0. The probability of success is the same for any two intervals of equal length. So you can't have a changing value if you have a small interval. And so for instance, the probability doesn't change from time A to time B. It's always the same probability. And the number of successes in any interval is independent of the number of successes in any other interval, provided the intervals are not overlapping. So we've got the Poisson probability distribution function. If x is the number of successes in an interval of fixed length t, then the probability of obtaining x successes in the interval is given by the formula where lambda represents the average number of occurrences of the event in some like 1 and e. Okay. So you can find Poisson distributions. They are actually on your calculator, so you're going to push second bars because that will take you to distributions. And then if you push the up arrow, you can go to D and you'll see Poisson, you'll see PDF, and obviously you'll need to know the mean and the number of occurrences. Okay. And obviously CDF follows the same rules as binomial CDF did. So you do have to keep those in mind if you're going to use it. Alright, so we've got a McDonald's manager. Actually what I'll do is I'm going to end this video here and I'll start a new one for this section.